Okay, we're back. So we're going to be looking at transformations, vertical and horizontal translations. So we're going to be shifting this guy left, right, up, down. The first one, we already know that if it's outside the sine function, it's vertical. That's going to move it up or down. If it's inside the argument of the sine, and that's what those brackets are, it's the argument of the sine, then it's going to be horizontal. So this is outside, is what I like to say, vertical. Inside, horizontal. And because we're dealing with trig functions, if you really want to impress people, horizontal shifts are also called phase shifts. Okay? So they are also called phase shifts. Vertical translations. We're just going to talk about those right now. A lot of words up here. Don't really care about it. Let's just jump right in and do it. Let's take a look at sine x plus 1. And let's compare it to y equals sine x. So let's sketch this one first, and then we're going to sketch this one. So the sine x, I'm going to start by doing 90 through 180, 270, 360. I'm going to give this 1. I'm going to make that negative 1. And that means that the sine curve, and you should be bored about this at the moment, but I don't know, it's kind of fun. I keep doing it, so I never forget. There's my sine curve. Purdy. Nobody asked me for the sine curve. They asked me for y equals sine x plus 1. That's a vertical shift up 1. All of the points are going to move up 1. So this point's going to move up 1. This point's going to move up 1. This point's going to move up 1. This point's going to move up 1, and this point's going to move up 1, which gives me the new curve. The whole thing has moved up 1. Do you see that? Okay. Now, be very, very careful. My scale, I said that 2 hash marks was 1. I didn't go up 1 hash mark. I went up 1 unit. Okay, and that was designated by the scale that I gave it. Now, if I was to do this using mapping notation, it would look like this. X sine x is being mapped onto x sine x plus 1. Now, you guys are understanding how mapping notation works, right? You take the critical points that are on the sine curve, those never change. And if you don't know them by now, you better sit down and memorize them. Those never change. Hold on, I'll make it bigger. I got people squinting at the back. There we go. Is that better, squinters? Okay. Now what's going to happen is these are going to be mapped onto the new points based on this new equation. And what does the new equation say to do? It says to add 1 to the y value. So it used to be x is 0. Okay, that's fine. Sine x it used to be, but now it's sine x plus 1. So 0 is sine x plus 1 is going to be 1. X, fine, they're both 90. Sine x is 1. Sine x plus 1 is 2. 180. So it's 0 plus 1 and 1. 270. Negative 1 plus 1 is 0. And then 360, 0 plus 1 is 1. And so each one of these points on my original curve gets mapped onto these new points, which means 0, 0 goes to 0, 1. This one goes to 0, 92, 180, 0, 270, 0, 360, 1. And what I have is my new curve. Both ways are great. The strong math student will be able to do both and will choose which they want. Okay? Yeah, that's it. Let's look at the next one. Y equals sine negative 2. Let's do this one with just point notation first, because I've never done that, have I? I've always... Okay, so here's point notation. It's going to look like this. X sine x goes to x sine x minus 2. So I got to know all the important points that are on the sine x for one curve, and that's going to be 0, 0, 90, 1, 180, 0, 270, negative 1, and 360, 0. They're going to map. That's why this is called a mapping. They have the same x value, so it's 0, but it's going to be 0 minus 2. And it's going to be 1 minus 2, which is minus 1. And it's going to be 0 minus 2, which is negative 2. And it's going to be 270 minus 1, negative 2 is negative 3. And then it's going to be 360 minus 2. So now the game is to plot all of these points. So I need 90, 180, 270, 360. I'm going to go, well, I got to be careful. I'm going to make this, I got to go down to negative 3. So if I make this 1, I'm going to fall off my curve, but it's okay. That's negative 1, that's negative 2. Negative 3 is right here. This needs to be extended just a little bit. But it's going to make for a prettier graph, right? It's going to make for a pretty graph. Okay, so now let's plot these points. 0, negative 2, boom chakalaka laka. 90, negative 1, boom chakalaka laka. 180, negative 2, boom chakalaka laka. 270, negative 3, ooh, boom. And then 360, negative 2, boom. Take a look. Now, this horizontal line, this axis, has been moved down 2 units, right? The horizontal line has been moved down 2 units, so that if I draw it, it's going to make my life easier in being able to do this. And that is the curve y equals sine x minus 2. And we did it in one stop shop without putting in the other curve. That's the value of point notation. I'm going to stop the video here and I'll be right back.